this new video. So the last time we talked about the internals of Node.js, we explored how Node.js actually works and the how powerful libuv is. And we know that through libuv, Node is able to achieve asynchronous um, operations or processes that and the interesting part about libuv is that it's a cross-platform, so you can use it on multiple platforms, which is really cool. So today we're supposed to dive into Node.js, the actual coding of Node.js. So we should be able to start at least basic things, not basic things, but we should start at least doing some code. Okay, as so to quickly recap, we know that so we kind of have so this is Node. We have libuv here, so we can write uh, libuv right there, and so libuv is right there, and then we have um, bindings, and then we have um, this is Node. So things happen like this. And then there's also, so when everything comes into place, we have like a callback queue. So whatever function comes in first, say an asynchronous function, and they keep piling up, and then whichever comes, so this gets executed, and then as calls come in, they leave accordingly. Okay, so libuv has this internal. So the way libuv actually processes things is that it has what's called loop, event loop, and then we also have so within the event loop there is the callback queue that we talked about here. So what really happens here is that as so each event that comes into the queue is processed first, obviously. So the event loop keeps track of who came in first and who should be processed first. So if this one comes in first, so as events gets added, this gets pulled up top, and the event, so the queue is executed one after the other. There's also another thing to keep in mind, which is the event loop. So the event loop, all right, hold on. So the event loop has four phases. It has one, two, three, and four. So the first phase is timers, is what we call timers. Um, the second phase is what we call IO. I believe, yeah, it's IO, input output. And then we have set immediate, and then close, nope, close callback. Let's see, input output operations or calls. So when the event loop actually, so what actually happens with the event loop is that there are a few phases that needs to be executed. Well, the first phase would be timers. So event loop would go through all the timers that exist. So for every cycle, so this is for every cycle, the event loop would go through all the timers and execute them first, and then go through the input output operations and then execute them next. Set immediate, of course, set immediate is one kind of timer, but it's usually executed after input-output operations, be it network calls, whatever it is. So this set immediate comes after. And the timers we kind of have, we actually do have like three types of timers. Um, the first one would be set time at, obviously. Set time at, we just, and then we also have set interval, and we also have set immediate. So we know what set timeout is. So basically, you run this code after X amount of seconds. Set interval is running the function in intervals. So you would repeat this function after a given period of time. Set immediate means run the function right away. But obviously, this doesn't mean like it's right away. So for one, it comes after input-output operations. And then there's also another phase in the event loop, which is called close callbacks. It would execute all the functions that exist in the closing um, statements of the input-output operations and the input-output callbacks, obviously. So it would execute whatever is in the close callback, and then for the next cycle, it would still repeat the same thing over and over. So with the event loop, um, utilizing Node and libuv for the servers is possible. Okay, so now you might be wondering, why would I go through the trouble of actually, picking up Node.js? Well, we know like we have uh, Python, we have PHP, and the likes, Ruby too. Well, talking about PHP and Python, like it's a single-threaded. It's not a single-threaded. Oh, yeah, it is. It is a single-threaded, and for it to be used in the server, you have to use either Nginx or Apache, or you have to have a server. You have to have something like Nginx or Apache to be able to handle concurrent requests to the server. With Node.js, you don't really have to because the internals are able to use the event loop. Like with the internals are made in a way that it delegates all the requests that come in. So unlike Python or PHP, um, so with Apache, it creates different threads for the requests that come in. And that kind of requires a lot of resources. And like with Node.js, the internals of Node.js allows you to have concurrent requests happening at the same time because with how libuv is actually made and the event loop and what the event loop does, it queues everything and delegates whatever it can to either the processor, which is by architecture is actually multi-threaded, or would have like a thread pool that's available and existing for whatever calls that do not go to the processor itself. So this means like if you end up using a server, like if you end up using Apache or Nginx or the likes with Node.js, you can imagine how incredible delegating or asynchronous calls might be happening. So yeah, now let's move away from this. We've been talking a lot of theory. Okay, so there's also another point to consider, which is what's Node.js really good at. And it's very important to have this realization where, so Node.js is not for all types of applications. So if you're using machine learning, if you're developing machine learning applications or CPU intensive applications like video processing application online or something, you'd have to avoid, well, you can have the control be done in Node.js, obviously, where input output operations are quite intensive, but you cannot have the processing itself done in Node.js, JavaScript, or the likes. So uh, CPU intensive calculations, applications that utilize the CPU intensively are not, suitable to develop in Node.js. But any application that requires intensive input-output operations, then by input-output meaning reading off database, communicating with other servers, and stuff like that, then Node.js is the one for you. So anything that requires delegation, input and output, Node.js is for it. Okay, so we've actually had, so we started to, so we're actually starting to, get acquainted with Node.js. Now, there's something we should start working on now, which is, um, so we have what's called the observer. Let's start here. The observer, sorry, the observer pattern. So what's the observer pattern about? It's very simple. So now we have like a figure. Say, let's call this a figure, and then we have audience, and then this audience uh, are interested in knowing about the figure right here. So they subscribe to the figure. So we got these people interested and these people not interested. So whatever this guy does, these guys know. But these folks are not subscribed, so they don't really care about what this guy does. So this is the main concept of observer pattern. And this is very handy in Node.js because you'll have to work few things, which is for starters. Say, for example, you create a callback. You want to emit a function, let's say emit a command, and if that command is sufficed, then the receiver would reply back and send you a confirmation. And this is achieved through what's called the Node.js code emitters, and we can see it here. Um, we have, so there's this instance of the class events, and these is, so you subscribe to different events based on the keyword on, and you emit an event using the word emit. So what's really happening here is that you created an instance of events, and then you created a new object to the class, and then for that object you created a subscription. You subscribe to an event named event. So if this event is emitted, then you um, you know print an event occurred. And then lastly, you emit the event itself. So this is the concept of the core. This is how things actually happen in it. Now let's try to create a new file. Let's call it emitters, ev im. So event emitters. I think this should do. So now let's go for constant event. It's a class event uh, emitter, which equals require events. I think something wrong. I'm using like a new keyboard and just kidding. So event emitter. So is this, so we have a constant event emitter, and then now we can create a new instance of it. So what we can do is constant event im equals event emitter, which is new. So this has to be new. So it creates an object in that instance. I'm gonna need to, I think it's double T. Yeah. Okay. Um, we need to fix this palings that we have. Emitter. Okay, so this is the new event emitter, and then let's call the instance of the event emitter to be let's call it soccer player. Let's call it Ronaldo. Let's call it Ronaldo. So Ronaldo is an event emitter, and then we need to subscribe to different emitters. So Ronaldo dot on if say score, then we pass in the function, um, and then we can say, for example, result. Then we can go console.log Ronaldo scored goal, and then we can supply in the result here like that. And then we can have another instance where miss a goal, and then the result console.log Ronaldo missed the goal. We can practice some JS stuff. So instead of this, we can use this. And then we can supply the result like so. I think that's how it is, right? Yeah, we can add a little bit of brackets like so. All right, and then so if Ronaldo scores or Ronaldo, so if Ronaldo scores or misses, then we emit, we can emit, and then the event name, we can supply string, which is win, and arguments, let's say in one. Then the Ronaldo, the emit, then we supply in not a win, miss, and then we can go, what do we supply here? Ronaldo missed penalty, and then instead of your score. So this is the event name. So let's try and okay, let's do node events. Okay, Ronaldo scored a goal 1, and Ronaldo missed penalty. Okay, let's make it more. Let's make it. Now this should make more sense. Ronaldo scored 1 goal. Ronaldo missed penalty. Let's see if this actually. Let's do another one. Missed corner kick. Exactly. So now we kind of, if we take a look at our, so this is Ronaldo, and then we specify that on score and on miss, these people are subscribed to different events, right? So let's assume this scores to miss. So let's go for like, this is missing and this is the score, okay? So these guys are subscribed to misses, and these guys are subscribed to scores, like so. Yeah, so this is the observer pattern. Okay, so we've touched on the observer pattern, and now let's explore something new. Let's explore callbacks and So let's do callbacks, and also promises. So this is so we came to have this, and we need to like have a difference between this and promises. Now callbacks go like this. So let's open up code and let's do new file callbacks promises.js. So with callbacks, usually the way you would want to do them is you'd have, say, a callback, and then you'll have so in the callback, say, let's call this back um, buy purchase. Let's call it purchase. So purchase using $100 and a callback like a function that gets executed based on that callback, right? So if this is purchase for $100, if we purchase you using it for $100, I want you to also purchase $200, and then the callback function goes in here. If you purchase $200, I want to purchase $300, and the function callback is right here, like so. So and then it just it just expands to becoming what's called a pyramid of nested callbacks. It kind of gets ugly. Now let's do another one. Let's just fill in. If you purchase 300, I want to purchase $400, and then execute a function callback like so. So it kind of gets nasty with time as the code grows. It becomes ridiculously really hard to read and really hard to manage. This is where the promises come in handy. So instead of you actually, creating this such a nested mess, such a nested mess, you would have to replace all of this using what's called a promise. And the promises are very simple. So with the promises, you have something. All right, let's keep this one. Let's keep what we have written. Let's keep this one like so. Okay. Now with the promises, now what we can do is create a new promise. The syntax has to be memorized anyway. So we go like constant say uh, purchase equals new promise, and it takes in, and within the promise it takes in approved and rejected, resolved and rejected. Okay, it takes in resolve and reject. So it takes in resolve, reject. Now if it's true, if true, say we're assuming that it's true all the time, and um, it's true all the time. If true, resolve, we can do kind of message. In this case, we can go work. If to resolve, else, whatever other reason, we just go reject, failed. Now, this is a promise. Now, what we can do is purchase. So, now this is the difference between the callback and the promise. Uh, you just go with the keyword then, and then we send in the result. So the value and unrejected on promise, and then we can just go close the results. All right, let's try to run this and see see it in action. So now we can, what is this? Did I make this? I'm sure I've done this. Okay, let's comment this one out. And let's try to run this and see if it really works. Let's pull back. Oops. Okay. And this is the reason why this is not enrichable is because it's always true. So, all right, let's try this one more time. It has worked. So what we've done here, so we created a new promise with resolve and reject. So all promises come with resolve and reject. If it's resolved, this is what you should execute. If it's failed, rejected, this is what you should execute. So when you initiate a promise, so then the result of whatever happens in here, like whatever happens within the promise, is returned as a, so in this case, the result has the string work. So we can actually create a result. We can create number 3, for example, and then we will see number 3 being displayed right there. So this is what's, so this is the difference between promises and callbacks. I talked about callbacks. We can create this nested callback hierarchy, and we can achieve the same using promises. Now, in this case, say for example, we have this result here, and we want to make more things to that result. So what we can do is we can, let's say, add another string, say result, or you know what? Let's go by, yeah, worked. And then we can go result plus um, chained step. This is a chain step. Okay, we can go, this is a chain step. And then what we can do here is we can go another then, and then this time the result console.log result2. Let's do result2. Okay, see what happens here. Okay, worked. This is a change step. So this promise, so the promise that we currently have returned worked, and then the result worked is here. We chained another text. Let's try this using numbers. Let's say this is 3, and then we add 5 here. Would it add? Okay, interesting. So comparing the two, like this is a chained one, and in this case we can keep chaining with .then. Now we know that whatever is returned from here is passed through to here, and okay, it's clear. So now, like in short, with callbacks, we kind of go with chained, which kind of starts to get messy and annoying. But when it comes to readability and functionality as well, I feel like this would be very easy for us to actually manipulate data. So when we have a new promise, it takes in resolve and rejected. If it's resolved, this is the result that would acquire here. If it's rejected, we will still get failed here. And then we can do whatever we want with the result, in which we can also chain the promise again and do another call, for example. In this case, we had it like in this case, we had work chained with this text right here. This is a chained step, which we implement using the .then. Okay, I think this is very clear. So comparing these two, this is very readable, and this is not really that, great when it comes to readability. Okay, so this is so far we've touched on two main topics, which is the um, the event emitters, the observer pattern, design pattern, where we have an event and so when we have an event that you can subscribe to, and when that's something on anything that happens or anything that gets emitted, the dot on gets triggered. Like in this case, we have the dot on. We have like a celebrity called Ronaldo. On the event of him scoring, we would get Ronaldo scored. If in the event of him missing, whatever he misses in the game, then we will have the whatever he's missed. So Ronaldo emits a score, we get that printed out, and the rest goes on. And then the other important component that we've learned is the promises. So is you need to have resolve and reject if whatever is resolved and rejected gets passed to the dot then method here, and then you can do the manipulation and chaining of events accordingly. So another very important thing that we need to notice, that we need to consider, not notice, but yeah. Okay, so when we do the chaining, anything could go wrong within the promise. So if anything goes wrong, so this means that these functions are executed asynchronously. So if anything goes wrong in between, this is where dot catch come in handy. So dot catch, whatever is passed through to the dot catch, and then we just go console.log, and error happened. Okay. So it's very also important to notice that dot catch only gets executed for like it catches the errors for whatever is before it. So if we also try to add dot then here, and then we can go uh, result 3. If we go for result 3, then console.log result 3. Now this will get executed. See, this is a chained step and defined results 3. Result 2. So we can go for result 2 plus result 3. Okay, okay. So this is not really defined. Okay, so this is chain step result 2 console.log result 2. Okay. Yeah, we're not returning anything, so we're just inputting. So um, we just have to, so because they're actually throwing the result here, we're not returning anything like we done in the first one. And what we can do is we can go result 2. So result 2 gets returned to result 3, and if we work it join here, this is chained, and then we can go like result 3. And we should be able to see that. Now, the catch didn't really work here, but if we try to throw an error, say, okay, right, we can do this. Do throw error. Now this catch statement should work. An error happened, so we got an error happened, but this one later was actually executed. So in order for now, if we throw an error here, if we try to throw an error here, if we try to throw an error right here, then we will not catch that error. See, we get unhandled rejection. But if we move the dot catch below this, if we do the dot catch right here, then the error has happened. So the catch just executes whatever, sorry, executes whatever is before it. It doesn't execute whatever is below it. So you can throw this error right here and avoid. So in this case, everything works just fine. Oh yeah, we have result 2. Then what have we not done right? This is result 2. Yeah, we just do return because it's not explicitly. If we use the brackets, we have to explicitly mention it. There we are. Okay. Try promises with timeouts. Do you think that would work? All right, let's try this. Constant timer was a new promise. It takes in resolve, reject, and so I've done some timers. Not sure if I was recording this or not, but yeah, done a few tests. Now let's try to do this again. I'm gonna do this again. Delete all of it, and then okay. So we have constant timer 1, which equals a new promise, and then for each and every promise we have resolve and reject, and then uh, okay, so we want to set timeout resolve. So we want to resolve this in 100 milliseconds, and then we want to print ready. Okay, and then we have another timer. I don't want to copy paste it. I want to actually type it down because when I remember the muscles to remember, I have to type it. Sorry. New promise, and then we will have resolve and reject, and then we will have a yielding here. Set time at when it's so set time at we want to resolve it to 100,000, sorry, to 1 second. Set, ready, set, go. Set, okay. And then we can do the same right here. So timer 3. And then resolve it to 2 seconds. And then we're gonna go for go. Okay, and then to run all of them, we have this promise keyword, that's all. It takes in a string of values, a string of promises. In this case, we have timer, timer 2, and then timer 3. Dot then, the result is an array of responses. Dot then we have result, so the log result, like so. If we run it, we have 3 seconds to wait, 3 seconds and 3.10 seconds. So we have ready, set, go. What we can do now, even if we try to set this the longest, and this one just like a 1 second, and this is like 2 milliseconds, and ready gets executed first regardless, because what we've learned here, whatever comes in first is executed first. So the queue callback, the callback queue, whatever comes in first is executed first. And then, so the event loop keeps these things. We have, sorry, we have, so in the event loop, we have different phases. So it looks for timers. In this case, we have these timers in place. Timer, timer, timer. The first one goes in first, the second, and the third one. So this gets added to the callback queue. So we have timer, timer one, timer two, and timer three. So this one gets executed first, second, and third. Now, regardless of how long this takes, the first one takes. Now, say this one takes 10 seconds, you will still have to wait. Like you cannot, unless, of course, obviously, we can see that this ran on its own. We didn't ran all this together. So this, when running all this together, means that this and this and this run together one after the other. But in this case, we have this promise running before that, even though it's okay. So what if we try to move this one a little down and we have the purchase? Let's put the purchase right here and see. See, this one, the purchase promise got executed first because it doesn't have any timer. So this was delegated unless, so we have to wait for 10 seconds. So the set time at is actually delegated. You know, it's synchronous. And this is asynchronous too, but this is finished because the promise they all run together. And this is like a separate entity on its own, hence that. I think what we need to explore more is the promise draw. I need to draw a single promise when all the input promises fulfill, including intervals passed. Okay, now I want to know which one gets executed first. Okay, so here, if the second one settles more quickly than the first, then that's just what happens. But in our case, this one should settle before this, right? Set timeout. Unless what we talked about here, the timers gets resolved in a sequential manner, could be. We need to understand this. This question remains, which one finishes before the other? Now, why is timeout not? Console.log. What is executed first is encountered when it initiates a timer, callback function, or set time execute task queue. When promises is encountered is in micro queue. Flyers execute last call for. JavaScript. Reject A. Reject 50. True. So in this case, the guy is expecting true P3 and the promise set timeout reject A. Synchronously immediately at the point you call new promise. On logs before the timeout, but also before you even call promise at all. Runs much later, only after the callbacks run. I want to run multiple functional functions in sequence where the first. I tried to do it using a single wait, but I noticed that although the result of the second verse is displayed after the first one, it's actually running in parallel. $342 first batch, $342 second batch. Promise 1, promise 2, 3, 4, 5. Okay, why? So this should. Alright, I'll explore this more. I'll end this video here and say